Definition of empty set. Empty set. Well, what's an empty set? A set with no elements in it is called an empty set. A set that has no element is called an empty set or null set. We represent that by just curly braces with nothing in it. And another representation is O with no elements in it, or just a set with nothing in it. Both of these representing an empty set, no elements in those curly brackets. Nothing is there, it's just empty. Okay, so I expect you to ask, so you just represented a set, you defined a set. What's the cardinality of this set? What is N of empty set? N of empty set, or the cardinality of empty set. What is that? There is no element in it. All right. So you're going to say that, hey, the cardinality is just 0. For those of you who've taken statistics before, you use this empty set in order to define the cardinality of A union B. Remember that if you have in probability the N of A union B is the cardinality of the first set plus the cardinality of the second set minus the cardinality of their intersection. We're going to discuss this in set theory as well. But for those of you who've taken statistics and probability before, you saw this formula for the union of two sets. Of course, you can generalize the idea to more than 2 sets with 3 sets, but you're going to have more cardinality involved here. Well, now that we introduced the empty set, we're going to talk about the subsets of a set. Subsets. Okay. Think about a class. Suppose we have 45 students in our class. As you remember, I asked you guys to form groups, all right? We can divide this class into some groups. Okay, very good. Those groups are actually the sub-collection, subsets of the set class. These groups are subsets or sub-collection of our class. So officially we say that in general. We say that let S be a set. The subsets set S are sets with members of S. For example, let's write an example next to this. S is the very first set that we introduced in this class, A, B, and C. Okay. So for this set, we are interested in finding the subsets. First of all, if the cardinality or the size of set S is n, this is just a general formula for you, then there are 2 to power n, let's just call it k in order to avoid confusion with it n, k, 2 to power k subsets of set S. Just note that, a quick note, that empty set and S are also the subsets of S. Okay. Very good. Let us move on to the example that we have here. We know that the cardinality of this set is 3. So K is equal to 3. We expect to get 2 to the power K or 2 to power 3 subsets. So 2 to the third or 8 subsets. Okay, so let us form them. What are those subsets? The very first subset is set including A. The second subset is set including B. The third subset is set including C. Okay, subsets with cardinality 1. Now we're going to move on to subsets with cardinality 2. A, comma, B. A, comma, C, and B, comma, C. Okay, how many subsets do I have so far? 1, 2, 3, 4, 5, 6. 2 more left. But I already know that the empty set and the set itself are both subsets of set S. Empty set and S, which is A, comma, B, comma, C. We list all subsets of set S. Just write down here. The collection of all subsets. We represent this guy using a power set notation. We say that, hey, P of S or power set is the set including all subsets of set S. So what you're going to do, you're going to just list them all right here. That's going to be set including A, set including B, set including C, set including AB, set including AC, set including BC, empty set, and S itself. So these are members of the power set of set S. The set including all subsets of set S.